So these questions are all from a calculator paper. The first one, we've got a train that leaves every 25 minutes and then another one that leaves every 45 minutes. So we need to find out when the next time is that they're going to leave together. So we know that they left at 8 o'clock together the last time. So I would pick your bigger time out the two, which is in the 45 in this case, and I would just count up in 45s until you find one that's also a multiple of 25. So you can use your calculator, remember, to help you do this. So if we count up in 45s, it would go 45 and then 90. So then add another 45, so it's going to be 135. So if you're not sure if these are multiples of 25, you can always just check it on your calculator. So for example, 135 divided by 25 is 5.4, so that's not obviously a multiple of 25. 25. So if I add another 45, that's going to make 180. So again, you could check, is 180 a multiple of 25? No, it's not. So add another 45 to get 225. So when you do 225 divided by 25, that is now 9. So therefore, that is the first number that's going to be a multiple of both 25 and 45. So we've actually got to work this out though as a time. So we know that it's going to be 225 minutes after 8 o'clock. So if we change this into hours and minutes, so 225, well, we know that 60 minutes in an hour. So 4 hours would be 240, which is too big. So it must be 3 hours and then so many minutes afterwards. So 3 hours would be 180, because it's 3 lots of 60. So I need to do 225 minus 180, so that is 45 minutes. So all I've got to do now is just add that on to the 8 o'clock, and so it would be 11 and then 45, and that's AM. Question 2. So it's a ratio one where we've got sherbets in this ratio and we've also got sherbets in this ratio. So it's always worth just checking which number is talking about the one that is actually the same. So in this case it's the 3 and then in this ratio it's the 7. So before we even start this question we want to make these the same. So I would have to times this ratio by 7 and this one by 3. So this would make this one 14 to 21. So that's the mints and that's the sherbets. And then this one, if I times it now by 3, would be 21 to 15. And the 21 is talking about the sherbets on this one, so that's why I've put it into the same column. And then the 15 is the toffees. So we've got to work out what fraction of the sweets are sherbets. So if I work out first of all the total, so just be careful that you don't add the digit that we've made the same twice. So it's going to be 14 plus 21 plus 15. So that makes a total of 50. So what fraction of the sweets are sherbets? Well, I know that it's 21 out of the total, so it should be 21 over 50. The next one is multiplying out double brackets, so you can either put it into a grid or use FOIL. So whichever way you do it, you should get the same answer, and you're doing the same multiplication. So 4x times x is 4x squared. 4x times minus 3y is minus 12xy. Then we've got y times x, so I could write that as either xy or yx. I'm going to write xy just because that's what I did there. And then y times minus 3y is minus 3y squared. So that is the multiplying out part. We now need to simplify it. So x squared, there's no other x squared, so therefore that will stay as 4x squared. We've got minus 12xy plus an xy. Or you might think it's easier to start on xy and then take away 12xy. So if you've got 1xy and then you take away 12 of them, that is minus 11xy. And then again, this is the only y squared term, so that will stay as minus 3y squared. Question 4. We have got simultaneous equations for this one. It's just knowing, how do I know that's simultaneous equations? Well, we've got two things here that we don't know the amounts of. So whenever you've got two things that you don't know the values of, it will be simultaneous equations. So we know that 5 adult tickets and 4 children tickets cost a total of 78. So as an equation, if I use A for adults, C for children, so it would be 5A plus 4C equals 78. And I can do the same for this one. It would be, if I write it underneath, 3A plus 6C equals 63. So I'm going to solve these now simultaneously. So to do that, I want to make either the A's the same or the C's the same. The signs here are the same, so it really doesn't matter which one we make the same, the A's or the C's.